Hi, question number 2. State two difference between the distance and displacement. Distance, displacement. So the first is distance is a scalar quantity, and the displacement is a vector quantity. And the distance is referred to the path length. Okay, let's say you have the point P and you have the point Q, and this is the path from point P to the point Q. So meaning if you calculate the distance here, you must measure the distance here, the real path here, right? But if you look at the displacement refer to the initial point and the final point, and this is straight line here. So this is a initial to the final, this is a displacement. This is how you can differentiate between distance and displacement. Number 2. Continue to number B. A bus moving with initial u speed 20 meter per second and decelerate. Meaning decelerate is acceleration is a negative value of the deceleration. So now constant decelerate at constant rate 3 meter per second square. So the value here is negative because decelerate. Calculate distance travel by the bus before you stop. So now because this is value of u, so you can use the u acceleration, can choose the equation v square u square plus 2as, because the question asks you to calculate the distance travel before before it stop, bus stop. So meaning because you have the initial velocity 20 meter per second and you have the value of the acceleration, because you must use a negative 3 meter per second square because decelerates, so make sure you use a negative 3 here. And now you can find, okay, what is the value of the final v? It's not given by the question, but the question gives you information distance travel by the bus before stop. Stop meaning the v final is equal to 0. So now v here is equal to 0. So meaning you can find the value of the displacement as is equal to 67 meter. Right? Continue to question number C. A stone is thrown upward from the roof building with a velocity 50 meter per second at an angle 30 degree to the horizontal. Right? The height of the building is 40 meter. So the best is before you calculate find the solution, you draw the process here, the situation here. Start with you have the building, height of the building is, let's say the building here is 40 meter, right? And the next is you have object, stone, thrown upward. So when you thrown upward, the direction of the object is thrown upward with the velocity 15 meter per second with the angle 30 degree, right? Okay, and yeah, that's all information right, given by the question. So now the question asks you what is the maximum height. So the situation given by the question here, or you can, if you look at the, okay, this is the ground surface, right? If you draw the process from start, process stone on the top of the building and thrown upward here and reach the maximum point here, this is maximum point, and start moving downwards to the ground surface here. Okay, so the maximum height meaning here is the position of the maximum height before the object or stone start moving downward. So this is h or maximum height. So the maximum height from the stone from the ground here. So now the question asks you to calculate the value of the, let's say this is a H maximum from top to the ground level. Okay, so to calculate the H maximum, okay, you can use the vertical motion or y-axis, because the time taken, if you look at the look at the equation, you can refer to the equation as is equal to ut minus half gt square. So now we consider the direction now for the vertical only, from the top to the ground level. So we have a u for s for y, this is for y, right? So now because the s here is the displacement, so let's say the object is here, okay, for the vertical, right? And moving upward and moving downward, so meaning this is upward positive, downward negative, and after the pass through to the initial position and the object continue moving with the downward, so we say we have also negative, because the displacement, let's say this is S1 for upward positive and S2 for downward before touch the initial position and continue start moving downward here, and this is a S3. So because this is positive, this is negative, so S2 is equal, S2 and S1 is equal to 0, cancel. So the S here you have only S3. S3 is equal to uy here is the initial velocity u, this is u, right? But you must resolve to the uy here, resolve to uy here. Uy here is the, if I draw the diagram here, uy here is here, right? Or here, this is a uy, right? So let's say you have a y-axis and this is x-axis, so this is 15 and this is angle 30. So resolve to the, as we have already discussed in the chapter 1, you can resolve 15 here to the y-axis. This is u, this is a u y direction, and this is u x. So now uy here is the opposite. You can use the 15, right? 15 sine 30 sine theta time t minus half gt square. So but now in the information here not give you the value of the t, yeah, no value of the t. So I think you need you can use another equation, v square u square minus 2gs, right? I think this, try to the second equation here. So now because v square here, v square meaning the final velocity here, the final velocity here, if you look at the equation, okay, no need for you to consider the x3 first. You go to the x1 and x2 for the second equation here. Okay, so for the use for second equation, so the s here is consider s1 and s2, right? S1 and S2 here. So you just consider the S1. Let's say you consider the S1 here. So refers to the S1, right? So meaning the S1 is from the ground here. So the ground to the top level or maximum. Okay, S1. This is upward process before downward process. So we have the S1 is S1. Okay, so from the equation, because V here, V maximum, right? So V at the maximum point, after the stone reach the maximum point, before start to moving downward, the stone V is equal to 0. At the highest point, at the maximum point, V stop just before start moving downward. So V maximum is equal to 0, okay, or Vy here. And initial velocity, you can use the 15 sine 30 resolve, because this is initial resolving to the y vector here. So this is equal to 15 sine 30, right? Okay, and the minus 2g. S here is a h maximum, right? H maximum, right? So v final is equal to 0. So now here you can find the value of the h. H here, h maximum is equal to, you can use the calculator here, is 2.87. But 2.87 meter here is the distance from top building to the maximum point, maximum level here, or top level. But from the ground surface, because the question asks you from the ground surface, so this is 2.87, and you must plus the value 40 meter. So the h, total h is equal to 40 meter plus 2.87, so you have 42.87 meter. So maybe you can use another equation, or use another solution, but I think to calculate the h here from the ground surface, you can use the v square u square minus 2j, right? Okay. Continue to number 2. Okay, again we have the situation, the same situation. Number 1, we have this is the stone thrown upward with the angle 30 degree with the initial u 50 meter per second, right? 50 meter per second. So now here we have a y-axis, so we have a x-axis, so you can resolve to the u, y, and direction here is a u, x. Resolve vector 50 meter per second u to the y-axis and the x-axis. So now this is the motion of the path of the motion of the stone before touch the ground surface. Okay. So now the question number 2 asks you to calculate the velocity, the stone just before it strike the ground, meaning the position of the stone here just before, let's say just before the stone touch the ground surface. So still stone have the velocity, and the stone have the, you can resolve velocity here to the v here, right? V here is the vx direction to the x, and also we have a vy here, right? Vy here. So now the equation asks you to calculate magnitude velocity. So what is the velocity here? So now if you refer to the situation here, we have vx, we have vy. So I draw here the process here is you have a, first you have a vx, and the second v you have a vy, and you have the, this is the, let's say we have the real v, this is v here. Okay, v, you want to calculate v here just before touch the ground surface. So if you know the value of the angle here, let's say theta, and you draw the triangle here, this is vx, this is 90 degree, and this is vy, and this is, so this is vx to the right and vy is downward. So you can use the trigonometry we have already done for chapter 1, right? So meaning you have a this is vy, you have vx, and you have the angle, you can find the value of the v here. Use a trigonometry, right? But the question asks you to calculate the value of the v. So for the v here, we have a vx, we have a vx, we have the vy. So you can find the value of the v here using by the Pythagoras, meaning v square, vx square, and you can calculate. Okay, I draw calculate here. So v here is a square root, Pythagoras, right? This is a vy square plus vx square, x square. And now the value of the Vx is constant. As I said in the online lecture, the motion of the object, okay, along the projectile motion here, ux is ux, and this is ux, and this is ux. Okay, we have the constant fixed value of ux. So ux here is equal to here, meaning you resolve u to the ux axis, meaning you have a 15 cos 30. So here the Vx here is a value is a 15 cos 30. So the problem here is what is the Vy? Vy here, let's say Vy, this is also Vy, here we have a Vy, is changed because influenced by gravity g. So meaning you must find the value of Vy here first to use the equation here to calculate the V before touch the ground, V, right? Okay, to calculate the Vy, you can use the equation. Now I write here for the Vy, you can use the equation V square u square minus 2gs, right? And now we talk about the vertical because Vy, this is, we talk about the Vy, so meaning this is a Vy and Uy. Okay, so look at the information given by the question for the u1 here is initial, already you resolve to the y-axis uy, so we have a 15 sine 30, right? And the g is constant, 9.81. So what is the value of the s? What is the value of the s? So s is a total distance process here, up and down. But we talk about the vertical. For the vertical, if I draw the process for vertical motion, we have the up. We have the up here, like say S1, and at the maximum point, the ball start to moving downward, right? Back to the initial point. This is X2, and continue moving to the ground surface. Let's say this is the distance here is a displacement here is a S3. Because S1 is upward positive and the second one S2 negative downward, so this is S1 as S2 is cancelled, 0. The only you have S here is the height of the building given by the question is 40 meter, right? So now S here, but direction of the moving object to downward. So here is S here is you must use negative 40, right? Now you can find, use a calculator, you can find the value of the Vy is equal to 29.0 meter per second. And now you can have the value of the Vy here is 29.0 meter per second, and you can find the value of the V here using the calculator, and you can find the value V here is equal to Vx square plus Vy square, 13 square plus 29 square, we have 31.78 meter per second, right? So this is the value of the V just before it strikes the ground surface. Okay class, that's all. Thank you. See you on the next video.